Okay, in this video, I'm going to work out the homework from section 16B, and the problems were 27 through 43 odd. So the first one is number 27, and the problem is x minus 2x plus 3 under the radical equals 0. My first step is to isolate the radical, so I'm going to add 2x plus 3, square root of that, to the other side. I'm left with x is equal to 2x plus 3 under the radical. I now need to get rid of the radical. I do that by raising both sides to a power equal to the index. Again, these are all square root problems, so I'm going to square both sides. That will cancel the radical. I'm now left with x squared is equal to 2x plus 3. I now need to get this in standard form so I can factor it. So I will add 2 or subtract 2x from both sides. Get x squared minus 2x equals 3. Subtract the 3. X squared minus 2x minus 3 equals 0. I need to factor this now. Factors of negative 3. That when I add them will give me negative 2. And that's going to be x minus 3, x plus 1. I'll now set each factor equal to 0. I now need to solve for x. This one I'll add 3. This one I'll subtract 1. Now my two possible solutions are x equals 3 and x equals negative 1. Remember, on the square root questions, you must do the check. So I'll now check the answers. I'm going to plug each one in. So if I rewrite the original problem, and now I'll first check 3. So 3 minus 2 times 3 plus 3. I'm going to simplify what's under the radical. 3 minus the square root of 9. The square root of 9 is 3. 0 equals 0. This one works so far. So far I have one good answer. Now let's check the negative 1. Do the exact same thing, but plug in negative 1. So now when I plug in negative 1, I get negative 1 minus 2 times negative 1 plus 3. I'm trying to see if this will equal 0. Negative 1, simplify what's under the radical. Negative 1, and then the square root of positive 1 is 1. Negative 1 minus 1 is negative 2. That does not equal 0. So the solution of x equals negative 1 does not work. So my only solution for this answer is the x equals 3. The next question, number 29. It has the following: 3x plus 7 under the radical, and then 3x plus 5. Again, your first step is to isolate the radical. It is already isolated on the left side, so I am going to square it to cancel it. So that will cancel the radical, and now I'm left with 3x plus 7. I need to FOIL the right side. Once I FOIL 3x plus 5 squared, I get 9x squared plus 30x plus 25. I now need to get it in standard form, so I'm going to move the 3x over and also move the 7. So now I'm left with 7, 9x squared plus 27x plus 25. I need to move the 7. 9x squared plus 27x plus 18, and now that equals 0. I'm going to factor out a GCF before I try to factor the trinomial. My greatest common factor is 9, so I'm left with 9x x squared plus 3x plus 2. I now can factor the trinomial into x plus 1 and x plus 2. Again, set each of the factors equal to 0. Now, the 9 here, when I set that equal to 0, there's no variable to solve for, so I don't need to do anything with the GCF. I now set x plus 1 equal to 0 and x plus 2. Subtract 1, x equals negative 1. Subtract 2, x equals negative 2. Again, I need to check my solutions. So I'll first plug in negative 1. Again, my original problem was 3x plus 7 equals 3x plus 5. I'll plug in negative 1. 3 times negative 1 plus 7. 3 times negative 1 plus 5. The left side was under the radical. Negative 3 plus 7, I get 4. Square root that, I get 2. The other side I'll simplify. I end up with negative 3 plus 5 is 2. 2 equals 2. This one works so far. So now let me try plugging in negative 2. So 3 times negative 2 plus 7 under the radical. 3 times negative 2 plus 5. Negative 6 plus 7. This will simplify to 1. Square root of 1 is 1. Over on the right side, negative 6 plus 5 gives me negative 1. Negative 1 does not equal positive 1, so this solution of x equals negative 2 does not work. So the only solution here is the x equals negative 1. Number 31. This problem has 4x plus 5 under the radical minus 2 equals 2x minus 7. Again, my first step is always to isolate the radical. So I'm going to subtract the 2. 4x plus 5, the square root of that, is now isolated. 2x minus 5. I now need to square both sides to get rid of the radical. 4x plus 5. Again, I need to FOIL that binomial. It is a binomial squared. It gives me 4x squared minus 20x plus 25. I need to subtract the 4x from both sides. I need to get it into standard form so I can factor this. 24x plus 25, subtract the 5. 4x squared minus 24x plus 20 equals 0. I can factor a greatest common factor out of 4. And I'm left with x squared minus 6x plus 5 equals 0. I now can factor the trinomial. Factors of 5 that give me negative 6 are negative 1 and negative 5. I now set each of the factors equal to 0. Again, the GCF does nothing for me. However, I can solve the other two. So add 1, x equals 1, add 5, x equals 5. I now need to check both answers. So I can do the check over here. Again, my original problem was 4x plus 5 equals, or minus 2 equals 2x minus 7. I'll plug in the 1 first. So 4 times 1 plus 5 minus 2 equals 2 times 1 minus 7. So 4 plus 5, 2 minus 7. 4 plus 5 is 9. Square root of 9 is 3. And then here I get 1 is not equal to negative 5. So that answer, that solution does not work. So positive 1 is not a solution. Let me check the positive 5. Same problem, so 4 times 5. Plus 5 minus 2. 2 times 5 minus 7. 20 plus 5 minus 2. 10 minus 7. Square root of 25 is 5, and then 5 minus 2 is 3. 3 equals 3, it checks. So x equals 5 is my solution. Next question is number 33. And the problem is the square root of 4x minus x plus 3 equals 0. Again, my first step is to isolate the radical. So I need to add x to both sides. The square root of 4x plus 3 equals x. Move the 3. Square root of 4x is equal to x minus 3. Now that the radical is isolated, I square both sides. It cancels away the radical. I'm left with 4x. Again, it's a binomial squared, so I FOIL, and I get x squared minus 6x plus 9. Put it in standard form, subtract the 4, and I get x squared minus 10x plus 9 equals 0. I can factor the trinomial. It factors into x minus 1, x minus 9. I now set each of the factors equal to 0 and solve for x. So x equals 1, add 9, x equals 9. Again, I need to do the check. So I'll check it up here. Again, let me rewrite the original problem. Square root of 4x minus x plus 3. I want to check to see if when I plug in 1, if it will give me 0 as my answer. 4 times 1 is 4. I can go ahead and simplify 1 minus 3 and get plus 2. Square root of 4 is 2. 2 plus 2 is 4. 4 is not equal to 0, so the solution of x equals 1 does not work. Let me try the x equals 9. 4 times 9 minus 9 plus 3. 36 minus, and I'll go ahead and simplify negative 9 plus 3 and get negative 6. Square root of 36 is 6. 6 minus 6 is 0. This one checks. So x equals 9 is a good solution. The next question is number 35. And 35 has the square root of x minus the square root of x minus 5 equals 1. Again, my first step is to isolate the radical. So I'm going to add x minus 5, the square root of that, to the other side. I now have 1 plus x minus 5, square root of that. Next step, now that the radical is isolated, square both sides. And now I can go ahead and get the radical to cancel. I need to FOIL the binomial over here. Once I FOIL it, I get 1 plus 1 x minus 5, 1 x minus 5 plus x minus 5. The radical disappears. I can combine my like terms. I can add the 1 and the negative 5, and that will give me negative 4 plus x. and then combine these two and get 2 square root of x minus 5. I now need to isolate the radical again. So I will subtract the x. 0 equals negative 4 plus 2 times x minus 5. Add the 4. 4 is equal to 2 times x minus 5, the square root of that. I now square both sides to cancel the radical. I end up with 16 is equal to 4 times x minus 5. I'll distribute. And now I can solve for x. I'll add 20. I get 36 is equal to 4x. Divide by 4, and x equals 9. I now need to check. I'll do the check over here. Again, my original problem was the square root of x minus the square root of x minus 5 equals 1. When I plug in the square root of 9, 9 minus 5, and then 3 minus the square root of 4, and then I get 3 minus 2, 1 equals 1. It checks, so x equals 9 is a good solution. Number 37. The problem is the square root of x plus 7 plus 3 equals the square root of x minus 4. Again, your goal is to isolate one of the radicals. It is already isolated, so I'm just going to square both sides. I now need to FOIL the left side. So once I FOIL that, I get x plus 7 plus 3 times the square root of x plus 7 plus 3 times the square root of x plus 7 plus 9 equals x minus 4. I can combine my like terms over here on the left. I get x plus 16 plus 6 times the square root of x plus 7, again, equals x minus 4. I now need to isolate the radical again. Subtract the x. 16 plus 6 times the square root of x plus 7. Move the 16. 6 times the square root of x plus 7 equals negative 20. Again, square both sides to cancel the radical. I'm left with 36 times x plus 7 equals 400. I'm going to distribute. 36 times 7 is 252. Subtract 252. 36x is equal to 148. Divide by 36. X is equal to 148 over 36. I can reduce that to 37 over 9. I now need to check this answer. Again, my original problem was the square root of x plus 7 plus 3 equals the square root of x minus 4. I'm going to plug in 37 over 9 for x. I need to find a common denominator. It's going to be 9. So 37 over 9 plus 63 over 9. Over here, again, common denominator of 9. I'll change 4 into 36 over 9. I can add these and get 100 over 9. Over here, I get 1 over 9. I can square root and get 10 over 3 plus 3, and then here get 1/3. I can already see that they're not going to be equivalent. I could change the 3 to have a common denominator, make it 9 over 3. So I get 19 over 3, which does not equal 1/3. So that answer does not work. It was my only solution to try. So this answer to this question is no solution, because the only solution I came up with does not work. Next one is 39. I have x plus 2, or the square root of x plus 2, equals the square root of 2x plus 5 minus 1. Again, isolate one of the radicals. It is isolated, so now I square both sides. The x plus 2 comes out of the radical. However, I do need to FOIL the right side, and I get 2x plus 5 minus 1, 2x plus 5 minus 1 times 2x plus 5 plus 1. Combine my like terms here. I can add the 5 and the 1 and get 2x plus 6. I can also combine these two and get negative 2 times the square root of 2x plus 5. This side I'll drop down. Again, I need to isolate my radical. So I am going to, I'm actually going to move the radical over so it's positive. So now I have 2 times the square root of 2x plus 5 plus x plus 2 equals 2x plus 6. Again, I need to isolate the radical, so let me start moving the x and the 2 away from it. I get 2x plus 4, subtract the x, 2 times the square root of 2x plus 5 is equal to x plus 4. It is now isolated, so I can square both sides. 4 times 2x plus 5. I need to FOIL the x plus 4 squared. So this becomes x squared plus 8x plus 16. I need to distribute the 4. 8x plus 20. I now can work on getting it in standard form. Subtract the 8x. 20 is equal to x squared. Notice the x term cancels. Subtract the 20. Now I could either factor this as the difference of two squares, or I could have used the square root method. So if I go ahead and do this, this factors into x minus 2, x plus 2, and again set each of the factors equal to 0. Subtract 2, x equals negative 2, and x equals positive 2. I do need to check to see if they both work or if only one works. So I'll do the check here. Again, it was x plus 2, the square root of that, 2x plus 5, square root of that, minus 1. I'll check the negative 2 first. Plug it in for x. And I get square root of 0, which is 0. Over here I get negative 4 plus 5. Negative 4 plus 5 is 1. The square root of 1 is 1. 1 minus 1 is 0. So the answer of x equals negative 2 works. Let's try the other one. So again, plug it in. 2 plus 2. 2 times 2 plus 5 minus 1. Square root of 4. 4 plus 5. 4 plus 5 is 9. Square root of 4 is 2. Square root of 9 is 3. Minus 1. 2 equals 2, I have both solutions that work. So my answer is both positive 2 and negative 2. Next question is number 41. And that has the square root of 3x is equal to the square root of 5x plus 1, and then minus 1. Again, my radical is already isolated, so I'm going to square both sides. Squaring the 3x squared, or the square root of 3x, causes the radical to disappear. I do have to FOIL the right side. I get 5x plus 1 minus 1 times the square root of 5x plus 1. Same thing, and then 1 times 1, negative 1 times negative 1 is positive 1. Again, I have like terms here. I can add the 1s. So rewrite the 3x, 5x plus 2 minus 2 times the square root of 5x plus 1. Again, my goal is to isolate the radical. I'm going to add 2 times the square root of 5x plus 1 to both sides. I now have 3x plus 2 times the square root of 5x plus 1 equals 5x plus 2. I now need to isolate the radical again, so I'm going to subtract the 3x. I get 2 times the square root of 5x plus 1 equals 2x plus 2. Now that it's isolated, I square both sides. The radical disappears. I square the 2. I get 4 times 5x plus 1. Over here I have to FOIL that 2x plus 2, and I get 4x squared plus 8x plus 4. I now can distribute, and now I can start moving my terms over to the right side to get it ready to factor. So 20x is equal to 4x squared plus 8x. Subtract the 20x. I now end up with 4x squared minus 12x equals 0. My next step is to factor out a GCF. I can factor out a 4x, and I'm left with x minus 3. I now set each of the factors equal to 0 and solve for x. My first solution is x equals 0, and my second solution is x equals 3. Again, I need to do the check. And again, my original problem was the square root of 3x equals the square root of 5x plus 1 minus 1. So we can plug in 0, 3 times 0, 5 times 0 plus 1 minus 1. This gives me the square root of 0, which is 0. Here, 5 times 0 is 0. Square root of 1 is 1. 1 minus 1 is 0. This checks. So x equals 0 is a good solution so far. Let's check that x equals positive 3. So again, if I plug it in, 3 times 3 equals 5 times 3 plus 1 minus 1. 15 plus 1 minus 1. Square root of 9 is 3. 15 plus 1 is 16. Square root of 16 is 4. 4 minus 1 is 3. 3 equals 3, it checks. So I have another good solution. So my answers here are 0 and 3. And the last question, number 43. X plus 2, the square root of that, is equal to 1 minus the square root of 3x plus 7. Again, your first step is to isolate one of the radicals. It is isolated, so I can square both sides. It'll cause the x plus 2 to come out of the radical. However, I need to FOIL the right side. So I get 1 minus 1 times the square root of 3x plus 7. Same thing again. And then finally the last term, when I do last, the 3x plus 7 comes out of the radical. I can combine like terms. These two are like, and so is the 1 and the 7. So x plus 2 is equal to 8 minus 2 times 3x plus 7, the square root of that, plus 3x. I now need to isolate the radical again. So I'm going to add 2 times the square root of 3x plus 7 to both sides. 2 times the square root of 3x plus 7 plus x plus 2 equals 8 plus 3x. I'm going to subtract the x. 2 times the square root of 3x plus 7 plus 2 equals 8 plus 2x. Move the 2. 2 times the square root of 3x plus 7 equals 6 plus 2x. I now have the radical isolated, so now I can square both sides. 4 times 3x plus 7. I need to FOIL this left side, or the right side, so I get 36 plus 24x plus 4x squared. I can also distribute over here on the left, get 12x plus 28. Rewrite this right side, and now I can start getting my terms together. I'm going to subtract 12x from both sides. 36 plus 12x plus 4x. Move the 28. I now have 0 equals 8 plus 12x plus 4x squared. I'm going to rearrange it so I have the polynomial in standard form on the left. I now can also factor out a greatest common factor of 4. And I'm left with x squared plus 3x plus 2. I can factor the trinomial into x plus 2 and x plus 1. Set each of the factors equal to 0. Subtract 2. X equals negative 2. And x equals negative 1. Again, let's do the check. Again, the original problem was x plus 2, the square root of that, and 1 minus the square root of 3x plus 7. I'll check the negative 2 first. Plugging it in for x. I get square root of 0, which is 0. I need to simplify what's under the radical, and I get negative 6 plus 7. 1 minus the square root of 1, which is 1. 1 minus 1 is 0. That answer works. Now let me plug in the negative 1. So I'll check that one. Negative 1 plus 2 is equal to 1 minus the square root of 3 times negative 1 plus 7. I get the square root of 1, which is 1. Over here I get negative 3 plus 7. Negative 3 plus 7 is 4. So now I have 1 minus 2. 1 is not equal to negative 1. So this answer is out. And this solution is also out. So the only solution here is x equals negative 2. So that concludes the homework problems that you had to do for section 1.6b.